Hello everyone, my name is Kartikey Pandey. I'm a student of second year BTech, Computer Science and Engineering at Madan Mohan Malviya University of Technology. And today we are going to discuss about control unit design. Before starting the discussion about the control unit design, I think one should know what a control unit is. So let's see. A control unit is the part of CPU, Central Processing Unit, that fetches instructions from memory, decodes those instructions, generates control signals, and direct other components ALU, registers, memory, input output, etc. to execute them. So we can say that control unit is the brain of central processing unit CPU. It directs all operation by generating control signals that coordinate register transfers, ALU operations, memory access, and input output operations. So now let's move to control unit design. So there are two major approaches to designing a control unit. The first approach is hardwired control unit and the second approach is microprogrammed control unit. In this video, we will be focusing on the first approach, that is hardwired control unit. In the next video, we will be discussing about the microprogrammed control unit. So now let's move towards the discussion about hardwired control unit. So, as the name suggests, hardwired control unit is hardwired. Here, the core idea is that control signals are generated using fixed combinational circuits, gates, decoder, flip-flops, and there is no control memory. Let us read it. In a wired control unit, the control logic is implemented with logic gates, flip-flop, decoders, encoders, and other digital logic circuits. So everything is fixed and there is no control memory. In case you don't know about control memory, we will discuss about it in the next video where we will be discussing microprogram control unit where it is present. So here no control memory is present, therefore it doesn't have to fetch any data from the control memory. Therefore it is faster, which we will discuss later when we will be discussing about the advantages. Now we can understand it further by this block diagram of a hardwired control unit. Here we can see that we have input register, instruction decoder, we have various kind of inputs in instruction register, instruction decoder. Here we have various kind of inputs from system buses, from flags, and here we have step counter. Let's discuss in detail about the working of a hardwired control unit. From this figure, you can see that this is instruction register, which will where the fetched instructions will come, and then these instructions goes into instruction decoders, which decodes them and then feeds them to control unit. And control units take various kinds of input from system bus, from flags, and it takes this this step times from this step decoder and then generates control signals which are fed to various parts of the computer and perform various actions. Let's discuss the working of this hardwired control unit in detail. So, a hardwired control unit gets set of inputs from IR, which is instruction registers, flags, clock, system buses, etc., and transform them into a set of control signals. Like here we can see that it is getting input from IR, system buses, flags, and this clock, and then it is converting them into control signals. Now instruction decoder decodes the instruction loaded in IR, which is instruction register. So here we have instruction decoder. It decodes the instruction which was loaded in IR instruction register. Now, the sequence counter provides separate signal line for each step or time slot in a control sequence. So this sequence counter, it provides separate signal line for each step and time slot. After execution of each instruction, end signal is generated. Here we can see we have end signal. So after execution of each instruction, end signal is generated. And this reset the control sequence counter and make it ready for generation of control sequence of next instruction. So as you can see that this end signal resets the control sequence counter, and thus it makes the control unit ready for the control sequence of next instruction. Now, hardwired control units are generally faster and simpler in design, but they are also less flexible and more difficult to modify or update. As we have already discussed, that hardwired control units are based on the core idea that the control signals are generated using fixed combinational circuits. So they are simpler but less flexible because everything is fixed. So it is always very difficult to modify or update a hardwired control unit. RISC, that is reduced instruction set computer, are implemented with hardwired control unit. So it is an example which is implemented with hardwired control unit. Now let's discuss some advantages and disadvantages of hardwired control unit. Let's first discuss some advantages. One of the major advantages of hardwired control unit is it is very fast. And why it is fast? Because it is made of fixed combinational logic circuits. And it doesn't have any control memory, so there is no lag. That is why RISC are implemented with hardwired control unit. Now let's move towards the disadvantages. So one of the major disadvantages about a hardwired control unit is that instruction set and control logic are tied together by special circuits that are complex and difficult to design or modify. Since everything is fixed, therefore it becomes very complex and difficult to design or modify or update the circuit. If someone designs a hardwired computer and later decides to extend instruction set, the physical components in the computer must be changed. So for example, if I design a hardwired computer today and after 2 years I decide that I think I should extend the instruction set, then to be able to extend the instruction set, I will have to replace physical components of the computer. There's no other way to make any update to the hardwired circuit. Thus, it becomes prohibitively expensive because not only chips must be fabricated, but also old one must be located and replaced, which will be a hectic and very expensive task for anyone. Thus, it is very hard to modify or update a hardwired control unit, and thus it is very rarely used to make computers. Now we can further understand the hardwired control unit by taking an example of a hardwired control unit in a basic computer. Like here we can see that two decoders, a sequence counter, and logic gates are making up a hardwired control. The instruction register stores an instruction retrieved from the memory unit. This is the instruction register and it stores instruction which was retrieved from the memory unit. The 0 to 11 bits denote address, the 12 to 14 bits denote opcode, And this 15-bit denote mode. As we can read here, the instruction register consists of the operation code 12 to 14, the L bit 15, and bits 0 through 11, which store the address. Now, the operation code bits, that is 12 to 14, are decoded with 3 cross 8 decoder, as you can see here. And then these 8 decoded outputs are fed to the logic gates, control logic gates. And the last bit 15, is transferred to a flip-flop designated by symbol L. Here is the flip-flop. So it is transferred to the flip-flop and then it is fed to the control logic gates. Now, the first 12 bits 0 to 11 are applied to the control logic gates. Here, the 0 to 11 bits are directly applied to the control logic gates. Now, the 4-bit sequence counter can count from 0 to 15 in binary. Here we have 4-bit sequence counter. This can count from 0 to 15 in binary. It has 4 outputs and the output is decoded into 16 timing pulses from T0 to T15 with a 4 cross 16 decoder. This 4 cross 16 decoder decodes the output of the 4-bit sequence counter into 16 time pulses. So thus act as the sequence counter for the logic gates for the hardwired control unit. The sequence counter is incremented by INR, which simply means increment, or cleared by CLR, that is cleared and get ready for the next set of instructions. It all happens synchronously. So, I hope you have understood what a hardwired control unit is and understood about its advantages and disadvantages. We can summarize the hardwired control unit as that in a hardwired control unit, the control signals are generated using fixed combinational logic circuit. Thus, it is fast, but because of because of having fixed combinational logic circuits, it is hard to modify or update the hardwired control design, and thus it becomes one of the major disadvantages of the hardwired control unit design. So, in the next video, we'll be discussing about the microprogram control unit design. Until then, take care. We'll meet you in the next video. My name is Kartikey Pandey. I'm a student of BTech second year Computer Science Engineering at Madan Mohan Malviya University of Technology. In the last video, we were discussing about hardwired control unit. Now, in this video, we'll be discussing about microprogram control unit, which is one of the two major methods of control unit design. So, if you can remember, the core idea of the hardwired control unit was that control signals are generated using fixed combinational logic circuits, and there was no control memory. The microprogram control unit is opposite of that. Instead of generating signals using gates, we store small programs called microprograms in control memory. So each instruction is sequence of micro instruction. It is like writing a tiny program inside CPU to control hardware. Now let's read this. A microprogram control unit is implemented using programming approach. It is not implemented using hardware approach as it was the case in hardwired control unit. In microprogram control unit, the control information, that is control signals, is stored in control memory. And control memory is programmed to initiate the required sequence of micro operations. So here the control information, that are control signals, are stored in control memory, and control memory is programmed to initiate the required sequence of micro operations. Now, control memory contains microprogram, which is sequence of micro instructions that specifies sequence of micro operations. So, inside control memory, we have microprograms, and these microprograms are sequence of micro instructions, and these micro instructions specify the sequence of micro operations that has to be executed. Let's dive deep into microprogram control unit. A microprogram control unit is a control unit in which the control signals, that is control information, are stored in binary form, that is 0 1, as control word in a ROM chip called control memory. You must know about word, as words are stored in memory of a computer. Similarly, control word is stored in a ROM chip called control memory. And each control word in control memory contains a micro instruction, and these micro instructions specify one or more micro operations for the system. So a sequence of micro instruction is responsible for generation of a set of control signals. So these control word, which are stored in ROM, which is ROM chip, which is called a control memory, these control word contain micro instructions, and then these micro instructions specify one or more micro operations. And a sequence of micro instructions is responsible for the generation of a set of control signals. So, this control memory is assumed to be a read-only memory, which we have already discussed, within which all control information is permanently stored. And the address where these micro instructions are stored in control memory is generated by microprogram sequencer with the help of instruction register, which fetches instruction from the memory. Now we can understand it better by the following diagram of a control memory. Let me erase it. So here, this is a diagram of a control memory, which is a read-only memory. Now these are microprogram. It contains control word, which are written in binary, as we have discussed earlier. And these control word point towards these control word point towards micro operations. So the main task of microprogram control unit are micro instruction sequencing and micro instruction execution. And the microprogram sequencer generate the address for the micro instruction according to the instruction stored in instruction register. So this micro sequencer generates the address of micro instruction according to the instruction stored in instruction register, which was fetched from the memory. And these control words point towards the micro operations, and those micro operations are responsible for various control signals. Let's understand it further by this block diagram of control unit, microprogram control unit. So here we have this next address generator, which is microprogram sequencer, of which we have discussed here. Microprogram sequencer generates address of micro instruction according to the instruction stored in IR, that is instruction register, which is here. It is clock. These are external inputs. So let's see. This is a control address register, also known as CAR. So what does it do? We can read it here. The control address register contains the address of next micro instruction to be executed. So, this register, also known as CAR, the control unit address register, contains the address of the next micro instruction that is to be executed. Now we have this control memory, which is a read-only memory, and then we have control data register CDR. Let's see what CDR does. So the control data register contains the micro instruction to be executed. So as car contains the next micro instruction that is to be executed, the CDR control data register contains the present micro instruction to be executed. Now this control word goes to decoder and the control signals with CPU and control signals with system bus. And thus this next address information goes to the next address generator, that is microprogram sequencer. Here it is given that sequencer determines the next address from within control memory. So the sequencer determines the next address from control memory, and then this address is fed into CAR, that is control address register, which contains the address of next micro instruction which has to be executed. And the control memory, that is this control memory, is where micro instructions are stored. So when CAR contains the address of the next micro instruction, it points towards that micro instruction, and that micro instruction is stored in this control memory. We can understand it further by discussing detailed working of a microprogram control unit. So let's do this. The next address generator is called microprogram sequencer, as we have already discussed, as it determines the address sequence of micro instruction that is read from the control memory. Like here we have said next address information, which is decoded. And then the control address register CAR holds address of the next micro instruction to be read, that is microprogram counter. This symbol denotes micro. The control data register CDR holds the micro instruction read from the control memory. We have already discussed this, that it reads the instruction from the control memory and holds it. Now the control memory contains set of micro instructions. We have already discussed that. Micro instruction contains a word that specifies one or more micro operations through generated control signals. So each micro instruction contains a word, also known as control word, that specifies one or more micro operations through generated control signals. And when address is available in control address register CAR, the sequence issues read command to control memory. That is, if the address is available in control address register, which contains the address of the micro instruction that is to be executed next, then the sequencer issues read command to the control memory. After issue of the read command, the word from the address location is read into the control data register. So when the address is available in CAR, the sequencer issues read command and to the control memory, and then after the issue of the read command, the word from the address location is read and is written into the control data register, which contains the micro instruction that is to be executed. Now the content of CDR, control data register, that is micro instruction, generates control signal and next address information. Now the sequencer loads a new address into the CAR, control address register, based on the next address information, as we had seen earlier. Here is the read command. Now let's discuss some advantages of of microprogrammed control unit. So the design of microprogram control unit is simple, which is less complex than a hardwired control unit, because microprograms are implemented using software routines, while hardwired control unit was implemented using hardwares and fixed logic gates. That thus it is both cheaper and less error prone to implement. Because of being based on software routines, it is cheaper and less error prone. More flexible because design modification, correction, enhancement is easily possible. Of course, since it follows the programming approach, therefore it is flexible. And the new or modified instruction sets of CPU can be easily implemented by simply rewriting or modifying the contents of control memory. Because of the presence of control memory, we can easily modify things by simply rewriting or modifying the contents of control memory. Now, complex functions such as floating point arithmetic can be realized efficiently using microprogrammed control unit. One of the one example which is implemented through microprogram control unit is complex instruction set computer CISC. Now let's move to the disadvantages of the microprogram control unit. So one of the first disadvantages is that it is slow compared to the hardware control unit because it requires time to access the micro instructions from the control memory. And there was no control memory in hardware control unit, therefore it was faster. Now the flexibility that it offers is achieved at some extra hardware cost due to control memory and its access circuits. So to achieve this flexibility, we will need to implement the control memory and the circuitry to access the control memory, which comes at extra cost. So it is expensive. So I hope you have understood about what microprogram control unit is and understood what are its advantages and disadvantages. And you must have got an idea of how these microprogram control units work. So have a nice day. Bye.